So today we're going to cover Chapter 1, Section 8A. Today we're going to learn how to solve quadratic inequalities. So when we solve a quadratic inequality, we need to make sure that there is a 0 on either the left or the right side of our inequality symbol. So again, we're going to see these same inequality symbols, the greater than, the less than, or the greater than or equal to, or the less than or equal to. We're going to be graphing these. So again, remember, these are going to be an open circle or parentheses on the number line. This would be a closed circle or brackets surrounding the number on the number line. So what we're going to be doing, once we get a 0 on either the left or the right side, the quadratic equation that remains, we're going to solve that quadratic equation as if it's equal to 0. Those two numbers that we get are not our answers. Those are going to be the breaking points on our number line. And then we have to pick a test point. And usually the easiest test point is going to be 0. But if 0 is one of your factors, you can't use that number. So let's go ahead and try the examples. So for the first one, notice I've already got a 0 on the right side of my inequality. So I'm now going to solve my quadratic equation. I'm going to set it equal to 0. So I'm going to take x squared minus 2x minus 3, set it equal to 0. I'm looking for factors of negative 3 that will give me negative 2. Those factors are going to be a negative 3 and a positive 1. I now set each of my factors equal to 0. So x minus 3 equals 0, x plus 1 equals 0. I'm now going to add 3 to both sides. X equals 3, subtract 1, and x equals negative 1. Now, these are not the answers. What these solutions that I just found by setting the quadratic equation equal to 0, these are going to become the breaking points on my number line. So I'm going to go ahead and draw a number line here. I'm going to put the numbers on my number line least to greatest. So I put the negative 1 first, and then the positive 3. These two solutions that I found from the quadratic equation have broken my number line up into 3 sections. What I'm going to be doing is picking a number to plug in to my original equation. As long as 0 isn't one of the answers, that's the easiest number to test. So I'm going to pick 0. 0 is located right here in between negative 1 and 3. So what I'm going to do now is take my original equation, the x squared minus 2x minus 3 less than 0, and I'm going to plug in 0 for x. 0 squared minus 2 times 0 minus 3 less than 0. Notice these, all of this just becomes 0. So now I'm just left with negative 3 is less than 0. I have to decide, is this a true or a false statement? This is a true statement. 0 is greater than negative 3. So in the section where 0 is located, I put a check mark. On either side of the other two sections, those do not work. They get X's. So what's going to happen is once you split up your number line, you're going to see a pattern that occurs. So if the first thing is a check mark, then the next section would get an X. And then the pattern just repeats. Technically, you could plug in a number from each one of the 3 sections and then see if it works or not. But just know that when you solve a quadratic inequality, it'll always be the same pattern. So you only have to pick one section to do a test point. and I picked 0, and that 0 worked. It gave me a true statement. So this section here that had the 0 is where my answer occurs. So on WebAssign, it's going to expect you to graph this. And let me go over here so you can see it a little bit better. So the graph of this would be, the original problem was less than, so parentheses, joined in the middle. Now, you can also graph it with the open circles joined in the middle as well. Now, the first box before you graph it wants the interval notation. So this is going to be from -1 to +3, surrounded with parentheses. So bottom line, when your check mark is in the middle, then it's just going to be the two numbers. But if your check mark ends up on the ends, let's say it's over here, and the X is in the middle, then you're going to have infinities in your answer. Because remember, on your number line, over here is negative infinity and positive infinity. But we're going to see this coming up, where you're going to have the infinities in your answer. So the final answer for number 1 is the graph with the interval notation. Let's try number 2. Again, I'm looking to see if my inequality has a 0 on the left or the right, and it does. It's got it on the right. So now I'm going to go ahead and take my quadratic equation, set it equal to 0, and factor it. Now, if any of the quadratic equations can't be factored, then what you would have to do is use quadratic formula or complete the square. So I'm looking for the factors of -6 that will give me -1. And those factors are going to be x minus 3 and x plus 2. I now take my two factors, set them equal to 0. So x minus 3 equals 0 and x plus 2 equals 0. I'm going to add 3. X equals +3. Subtract 2. X equals -2. Now I need to put these numbers on the number line. And again, it needs to be placed on the number line from least to greatest. So I put -2 first, and then the +3. I need to find a test point. I either need to pick a number from this section, or this section, or this section. And honestly, the easiest place to pick a number is going to be 0. However, if 0 was one of your breaking points, you can't pick it. Okay? So again, I'm going to pick 0. Now, in most of the examples, except for one, my 0 always tends to end up in the middle. In the homework, that may not be the case. All right? So for example, if your two answers, let's say it was -3 and -2, then 0 would have been located over here. So wherever 0 is located, that's where you're going to choose to use it, and then that's where you put the X or the check, wherever the test point is located. All right, so now let's go ahead and plug in 0. And once I plug in 0, I'm plugging it into x squared minus x minus 6 less than 0. 0 squared minus 0 minus 6. This all is gone. -6 is less than 0. Again, it's a true statement where the 0 is located. So this gets an X, and then on either side, gets a check. Either side gets the X's. So this is the section that works. If you're graphing it, again, the original symbol was a less than, so parentheses, and connect it in the middle. My interval notation is just going to be from -2, 3, surrounded with parentheses. Now, number 3 is where we're going to see the X's in the middle, and you're going to see how you have to include infinity in your answer. So let's try number 3. So for number 3, let me just write it down here in the white area. Okay, so for this one, x squared minus x minus 20. It already has a 0 there, so I'm going to set it equal to 0 to get the breaking points on my number line. I'm looking for factors of negative 20. That will give me a negative 1, and that will be a negative 5 and a positive 4. When it's the simple trinomials like this, you don't have to go through the whole process of factor by grouping. If you choose, you can. So now I take each of my binomials, set them equal to 0, add the 5, x equals 5, subtract the 4, x equals negative 4. These now become the numbers that are on my number line that separate the sections. Again, put them on the number line from least to greatest. Pick a test point. I like to pick 0. You could pick 10, 20. It doesn't really matter, but the bigger number you pick, the bigger calculations you're going to be doing. So now when I plug in to my original problem, the x squared minus x minus 20, I'm going to see if I get a true or a false statement. 0 squared minus 0 minus 20 greater than or equal to 0. This ends up giving me negative 20 greater than or equal to 0. Notice this is a false statement, so the section that has the 0 gets an X. And then the two sections on either side, they get the check marks. Because again, it's always going to be a pattern. X check, and you can just repeat the pattern. Now remember, on your number line, you have negative infinity, positive infinity. So the graph of this, notice it was originally a greater than or equal to. So it's going to be a bracket pointing towards negative infinity, and then a bracket going to infinity. If you want to do the closed circle, you can do that as well. My interval notation, you read it left to right. So this one goes from negative infinity up to the negative 4 with a bracket because it had the greater than or equal to. Remember, infinities always get parentheses. And when it's these segments or these rays that point outward, remember we have to use the set operator, the union, and then it'll go from a bracket 5 to infinity. The U symbol is in the equation editor, that math pad. And if you click on the little box that says sets, that's where you can get the U from. So this is your interval notation. This is what will go in the first box before the graph. Let's try the next one. Again, I've already got a 0. So let me write number 4 here, because I've written all over the place. So 4x squared minus 5x minus 6, and I'm setting it equal to 0. You can either choose to guess and test to factor this. I'm going to factor by grouping. I'm going to multiply the beginning and the end. So two numbers that will multiply to give me negative 24, but who will add to give me negative 5. Those factors are going to be negative 8 and positive 3. So rewrite the first term, 4x squared. Replace the middle with these two factors you just found. Rewrite the last term. And now factor by grouping. Make a red group and a blue group. The greatest common factor of my red group will be 4x. My greatest common factor of my blue group is going to be 3. And now put the two GCFs together. 4x plus 3, x minus 2. And now set each of the binomials equal to 0. And this will be the numbers that I will put on my number line. 4x plus 3 equals 0. X minus 2 equals 0. Solve each one. Subtract the 3. 4x equals negative 3. Divide by 4. And my first breaking point on my numbered line will be negative 3/4. Over here, add the 2. X equals 2. Now again, if you get something like this in WebAssign, and WebAssign marks it wrong because you didn't place negative 3/4 appropriately, make sure that your graph and your notability is clear so I can go back and hand grade it if your grade drops below an 80. So for this one, I'm going to go ahead and put these two numbers on my number line. So I'll put the negative number first. Again, it's always least to greatest, then the positive 2. I need to find a number to plug into the original to see if I'm going to place an X or a check. I always like 0, so 0 is located right here in between the negative and the positive number. So I'm taking my original problem, which was the 4x squared minus 5x minus 6 greater than 0. Plug in 0. 4 times 0 squared, 5 times 0 minus 6. This is all gone. And then now I'm just left with negative 6 is greater than 0. This is a false statement. So the section that has 0 gets the X. And then the other two sides of that X get the check mark. So again, to graph this, the original symbol was a greater than. So it would be parentheses pointing to negative infinity and parentheses pointing to positive infinity. So my interval notation, reading the graph from left to right, will be from negative infinity up to the negative 3/4, parenthesis, because it was a greater than, then the union for that gap where the X is, and then it starts up again at positive 2 and goes to infinity. Okay, so for number 5, again, remember, you need to have a 0 on either the left side or the right side. So I'm going to first go ahead and distribute the X. I get X squared plus X less than 12. I now need to subtract the 12. And I get X squared plus X minus 12 is now less than 0. Now I'm going to factor this as if it's equal to 0. So I'm going to change this to a X squared plus X minus 12 equals 0. So my factors of negative 12 that will give me positive 1 will be factors of negative 12 will be positive 4 and negative 3 that when I add them give me a positive 1. I now take each of the binomials, set them equal to 0, subtract 4, X equals negative 4, add 3, X equals positive 3. Now, these are going to be where I break apart my number line. So here, I'll draw the number line, put them on the number line least to greatest. Figure out where you want to get a number to test. Again, as long as 0 isn't one of your answers, you can use that as a test point. So my 0 is located right here in between the negative and the positive. So if I go ahead and plug that in, going back to the original. So my original was X times X plus 1 less than 12. When I plug in 0, 0 less than 12, and then 0 times anything is 0. 0 is less than 12. This is a true statement. So the section that has 0 gets the check mark because I got a true statement. The other two sections on either side of the check mark, they get the X's. So my answer in interval notation, let me redraw it over here so you can see the graph. So -4, +3. So because the original symbol was a less than, parentheses joined in the middle, or open circles. In interval notation, -4, 3, surrounded with parentheses. So remember, when your check mark is in the middle, it's just the two numbers surrounded with the appropriate grouping symbol. When the check marks are on the ends, that's when you need infinities in your interval notation. Let's try the next one. So again, I need to get a 0 on either side of my equal sign. So what I'll do here is subtract the 16. And I get x squared minus 16 is greater than or equal to 0. So now what I'm going to do is solve this as if it's an equal sign. X squared minus 16 equals 0. I can factor this. This is the difference of two squares. So x plus 4, x minus 4. Set each of my binomials equal to 0. Subtract 4, x equals -4, over here add 4, and x equals +4. These become the numbers on my number line. Least to greatest, put the -4 first, then the +4. I need to find a number to plug back into the original to see if it's true or false. Again, the easiest number to plug in is the 0. So once I plug in 0 into x squared greater than or equal to 16, I get 0 squared greater than or equal to 16. 0 is not greater than or equal to 16. This is false. So the section that has the 0 gets an X, and the sections on either side get the check marks. That is where my solution occurs, where the check marks are. So any number less than 4, -4, or greater than 4 will make that a true statement. So in interval notation, because it's got the greater than or equal to, bracket, going to -infinity, bracket, going to infinity. So in interval notation, -infinity up to -4. -4 gets a bracket. Infinity always gets a parenthesis. And then from +4 up to infinity, 4 gets a bracket. Infinity gets a parenthesis. All right, number 7. Now, this one cannot be factored. I need to go ahead and get the 0 in here. But I'm going to go ahead and add the 1. And I get x squared plus 4x plus 1 greater than 0. There are no factors of 1 that will give me a 4. So when this happens, you either have to complete the square or quadratic formula. I'm going to do quadratic formula. So my a value is 1, my b is 4, my c is 1. I'm going to plug it into the quadratic formula. Opposite of b, plus or minus b squared minus 4 times a times c, all under the radical, divided by 2 times a. This gives me -4 plus or minus 16 minus 4, all over 2. Do not be tempted to simplify yet. We need to break down the radical first. This gives me 12. Again, don't simplify yet. Let's do a factor tree for the square root of 12. This will be 4 times 3, 2 square root 3. So now I've got x is equal to -4 plus or minus 2 times the square root of 3 over 2. Now I can simplify. I can simplify all of these by 2. So this will become a -2, a 1, and a 1. So my final answer here is -2 plus or minus square root of 3. Now, these are the numbers that go on my number line, and you're doing this without a calculator. So you're going to have to approximate it. So, for example, let's put it on the number line. -2 minus square root 3, -2 plus the square root of 3. So you're pulling this apart and making it 2 separate factors. Now, what we're going to do here is approximate the square root of 3. So I'm going to see which 2 perfect squares it's between. So it's in between the square root of 1 and the square root of 4. The square root of 1 is 1. The square root of 4 is 2. So the square root of 3 is somewhere in between 1 and 2. It's probably closer to 4. So I'm going to say it's about 1.7. Even if you do 1.5, even though it's not right in the middle. So now what I'm going to do is figure out what -2 minus 1.7 is and -2 plus 1.7 is. This gives me -3.7, and this gives me -0.3. So again, you're approximating the location. So both of these are negative numbers. So this is my approximated value. So when I go to do this now and get my test point, 0 is not in the middle. And you're going to have this in the homework as well. So over here is where my test point is located. 0 is over here because it's bigger than a negative number. So it's in this section, the far right. So now I'm going to plug in 0. My original problem was x squared plus 4x greater than -1. 0 squared, 4 times 0, that's all zeros. 0 greater than -1, this is true. So the section where 0 is located, which is over here, gets a check. Middle gets an X and a check. So now my interval notation, so graph would be the original symbol was just a greater than. So it'll be a parenthesis pointing to -infinity and then a parenthesis going to +infinity. So my interval notation will be from -infinity up to -2 minus the square root of 3 unioned with positive square root 3 here to infinity. Okay, so for the last one, I'm just going to rewrite the problem down here. We have 2x to the third minus 3x squared minus 32x greater than -48. I need to move the 48 to the other side. I need a 0 in my problem. Now, whenever we see a 4-term polynomial, this should be a clue that you're going to factor by grouping. So again, I'm going to solve it as if it's an equal sign. Because the solutions I'm going to get, and there'll be 3 of them, are going to be the breaking apart points on my number line. So I'm going to make a red group and a blue group. My greatest common factor is going to be, of the red group, is going to be x squared. After I divide, I'm left with 2x minus 3. My GCF of the blue is going to be -16. I now take the 2 GCFs, put them together, take the binomial in common, write it once. Now notice my first binomial there can still be factored. This will factor into x plus 4, x minus 4. And now set each of the binomials equal to 0. So I end up with x plus 4 equals 0, x minus 4 equals 0, 2x minus 3 equals 0. And now solve each one. Negative 4, positive 4, add the 3, divide by 2, and x equals 3 over 2, which is 1.5. I need to put these numbers on my number line from least to greatest. So here's my number line. Put the negative 4 first, then the 3 over 2, then the positive 4. I need to find a test point. And again, I can pick a test point from any one of these 4 sections. But I like to pick 0, and 0 is located right here, in between negative 4 and positive 1.5. So I take my original problem, the 2x to the third minus 3x squared minus 32x greater than negative 48. Once I put all of this in here, and then notice all of this becomes 0. 0 greater than negative 48. This is a true statement. So the section that has the 0 gets the check mark. And then the pattern starts. X, check, and then put an X in front of that one. So my graph here, the original symbol was a greater than. So this one gets surrounded, and then this one goes to infinity. So for this one, I'm going to have from negative 4 to the 3 over 2, surrounded with parentheses. This X is the U, and then it starts up again. And goes to infinity. Remember, your interval notation is the location of these check marks. So this is where it starts, and this is where this one was in between. So it's everything from that line up.